back, everybody. We'll just continue, shall we? So, thus far, we have covered the wildcards, be it the asterisk, which is a general wildcard where you can substitute practically an infinite amount of characters and any character, or you could have used a question mark, which would substitute only one character with any character. Now we're going to go ahead to something more specific or something more precise where you will be able to say, okay, well, I wanted to contain these characters, or I wanted to begin with these characters, end with these characters, or not contain these characters, or even contain this particular range, which can also be a very nice feature. Anyway, let's go ahead and give it a shot and see what happens. So if I type in LL here, I get a listing of all the files that I have in this folder as before. But let us say that I wanted to print out all the files that begin with, let's say, R. So I notice that I have the files random. So here, random and random with a capital R. These are two completely different things. As I do believe I have mentioned before, Linux is extremely case sensitive. Let's go ahead and type in LL space, open bracket, type in R, close bracket, and then place an asterisk so we don't have to type in the rest of the name of the file. Press enter, and there you go. You get two files which begin with R, but notice how we didn't actually get the file that started with a capital R. Now if we want to include that file, we would just type the capital R here. So we are telling the first field of the file name will either contain a lowercase r or uppercase R. This is not the second field, so this wouldn't be you cannot think of it as two fields, so the lowercase r and uppercase R are the same field. So this is basically equivalent to this. Either the first field of the file name will contain R lowercase or R uppercase. These are not two separate positions. Probably a better thing to say that they are positions as opposed to fields. Anyway, so these are not two separate positions. This is one exact position, except you're telling the machine it either begins with lowercase r or it begins with uppercase R, and then we are going to get it. Surely enough, you see that indeed we got 3 files printed out. Anyway, you can put this pretty much anywhere you want. You can put it depending on the purpose at hand, depending on the task at hand. You can substitute any position in the file name. So let me just give you an example of this. Now we are going to define the second position. Only when you open close the brackets again are you actually defining the second position, or the third, fourth, or last and second to last, because this could just as easily have been written out like this. And how do we want this file to end? Let's say we want it to end with E. Excellent. So we are effectively telling the machine all files that end with letter E should be printed out to standard output, and surely enough we get them here, no problems. But what I wanted to show you is defining other fields. So if I type in, I don't know, open bracket, and I say D, second field shall be O, close it, then we're going to put an asterisk here, and an asterisk here, and press enter. Well, a poor example here because they all pretty much contain DO except for the last one, but doesn't matter. I think you get the idea here. So it can be preceded by anything and it can end with anything. It contains a D character somewhere in the middle followed by an O character. And surely enough, all of these files, they do contain DO somewhere within their name, except for the last one, which you can see that it was not printed out, so the command was successful. Anyway, I could have also said DOM, So this would be this. We're gonna get pretty much the same output, but I just want to show you that you can specify multiple characters at. You can specify multiple positions, no problems. You could also have specified different characters at these multiple positions. So this one would have UIO and this one would have POL. This would be a huge amount of, well, maybe not a huge amount of combinations, but certainly a certainly a significant amount. Basically, what we said, it can contain D, E, G, S, F, oops, you shouldn't write it twice. And then it will be followed by either by U, I, or O, and then it will be followed by P, O, L, or M. This would be a pretty, we would be casting a pretty wide net with this, but it doesn't really matter. What I want to do here is demonstrate that you can specify multiple positions. Now, you can also say, oops, sorry, clear. You can also say that you want to exclude certain characters. If I type in LL, and if I type in the question mark is pretty much the universal negation, either in programming or here in Linux, in the Linux terminal. I can say, let's say that is excluded as the beginning of the file. And you will see all the files that began with is are no longer here. They can no longer be here as they are excluded. Just a exclamation mark means not, does not contain, and we are negating these two characters, therefore excluding them from our output. There is just one more thing that I wish to mention here, and those are the ranges. So for that purpose, I've actually created these files is random 0001, 02, 03, 04, and 05. Let's go ahead and see how that works out. Type in LL, give it a wildcard, or we can type in is random because we've used the wildcard before. I just want to show you that this does work without full wildcard. You can combine it also with words, letters that you know from the file name. And I'm going to say underline. So for the second to last character, which is, we can see the second to last are these characters here. I can see that they're all zeros. So no need to give it a range. I can just type in 0. Next to that, I can open up a bracket and say, okay, now I would like to have a range here. The range shall be from 0 to 5. Close the bracket. And surely enough, only those files get printed out without any difficulties of whatsoever. Now this should work like this as well. There we go. So they all get printed out once again without any problems of whatsoever. I have left the underline there. Not sure exactly why, maybe just missed it, didn't see it, but doesn't really matter. Even if this underline wasn't here, as I said, asterisk stands for any character, absolutely, so no problems there. Anyway, you can inject these ranges pretty much anywhere you want within your file and place text in front, in behind, or even in between. And then you can also give it wildcards and stuff like that. I strongly recommend that you experiment with this as much as you can, as these are some of the things which will be used to a rather large, these are the sort of things, these tricks, so to say, that are used by network administrators all the time to generate scripts which automate tasks, primarily because you won't always know the names of the files and you will need to use them. Of course, you can use locate or find, but to actually run locate or find every time to search through the whole system for the sake of file names is resource expensive, and you don't really want to do that. Rather, instead, when you need to, for example, grab a file name, put it into a script, a bash script, and then do something with that file in bash script, usually edit it, change it in some way, change some values in it, then you would use things like these to pull the file names out of a, let's say, out of a configuration, out of etc or out of log directory, and then you would do it. For example, logs, if you're logging if you're logging some sort of activity, if you want to see what is going on and you've enabled logging, we will deal with this subject more extensively later. But what you say is that, okay, this log gets created now for the activity of the file, and then after a certain amount of time has elapsed, I want you to stop writing to that particular file, create a new one, and continue writing the log so that your individual log files are not too big. And you can manipulate them with greater ease, and they are segmented so you can delete certain parts of it more easily, and so on and so forth. But the naming of those files is basically by index. So you tell the bash script to name the files like 0001 and so on and so forth. Usually would place a date here so you know when it is actually done. If this is not sitting too well with you now, don't worry. I don't want you to worry about it. We will deal with these sort of subjects later on. I'm just giving you an example here of what this particular thing that we have just done is used for. You would want to say, I don't know, list me all the log files that contain a particular month or a year or something of a kind. So you would just put in like a wildcard, and then in the ranges, in this range, you would be able to type in the date pretty much. You would give it a range here in the first one, and then you would give it a second range. So, well, actually, you would just use two. You would type in the range for the month. Which months do you want to be included? I don't know. Like, you obviously wouldn't be able to type in 0 for a month. Rather, instead, you would say from 6th to 8th month in the year 2014. It's 2015 now, but I'm just using a reference. So all the files which contain these sets of numbers shall be printed out. Basically, the month and the year. You want to print all the log files that were made in between the 6th month and the 8th month. That's one way to configure logging. There are of course others, but usually they configure them by date, and this would be one of the methods. Roughly, this is not the correct syntax because you would actually need to see the file name to figure out the correct syntax. You would probably need to put something in between here, like a minus sign or something of a kind, and then this would make far more sense. But I wouldn't just put a minus sign. I would go about things like this, and this would be very nice. Obviously, if I press enter, ls cannot access no such file or directory. There is nothing under such name in my desktop folder. But doesn't really matter. That's not what I wanted to do today. This is just what I want. This is just an example that I wanted to give to you so that you would understand this with greater clarity. So you see what I've done here. If I am in the folder where the logs are made, I can tell it, okay, all the log files that were made in between 6th and 8th month, 6th and 8th included. Now this is just a syntax. You usually would have a minus separating the month from a year, and then you can specify, okay, these months for this particular year. Then please pull the output, and you would usually put something like this, like grep, and there would be a particular line or something of a kind that you would want to pull out, so you would give a matching expression here, which would be like which would be login. So there could be a line login, and you would pull everything that contained a word. You would pull all the lines that contained word login in between on these particular dates. Anyway, as I said, if this last part is not sitting too well with you, it's perfectly fine. It's perfectly natural, and just like introducing new subjects at random. And when we actually get to them, you will be at least familiar to a certain extent. But what is important for you to understand today in this particular tutorial is the idea of globbing. So I've had two tutorials thus far on globbing. We've done the wildcards, we've done single character wildcards, we've done particular characters, negating the particular characters, ranges as well. So these five basic ways of these five basic filters, I would say, I would strongly urge you to know them and learn them and experiment with them, primarily because you will be using them extensively as a Linux administrator. That would be all. I would like to bid you all farewell and a ton load of luck. Until next time.